right. The second type of special case that we're going to talk about is called a proportion. Okay, and a proportion is just a little bit different because it creates a ratio. And we talked about ratios a little bit. I know that you have in the past math classes. But basically you have a ratio is equal to another ratio, and that's a proportion, and so we can use that. So these are solved a little bit differently. It's why I'm going to call it a special case, because it's solved differently than the way we would normally solve a multi-step equation. Okay, so I'm going to show you the steps for a proportion. So first off, so remember that a proportion is if we have A over B is equal to C over D. So it's a fraction basically is equal to another fraction. So starting with step 1, you're going to cross multiply to solve this. Okay, and it's the same as if you were doing a regular proportion. And I know that you learned how to work with proportions in the past. This time we're working with proportions in terms of an equation, so there's going to be some variables involved, but we still solve using the same method. We're going to cross multiply, which means A over B is equal to C over D. To cross multiply, we would multiply A times D and set it equal to B times C. Okay, so we multiply the opposite corners and set them equal to the other multiplied opposite corners. Alright, and then we move to the second step, and the second step is to distribute if necessary. Okay, if there's anything that we need to distribute, we will do that. And then the final step is to solve it, just like you've been solving the others. There may be some things you have to combine, there may be some variables that you have to move to one side or the other, but those are going to continue to be the same steps as previously. Okay. Alright, so here's what we're going to do. We're going to start with a few examples. So 4 times 6 is the first step. We're going to do 4 times 6 is equal to 3 times x. Alright, that's our cross multiply. So we end up with 24 is equal to 3x. Okay, and then we're going to divide by 3, and x is equal to 8. Okay, so we cross multiplied, there was nothing to distribute, so we went ahead and solved it just like a regular equation. So let's look at number 2, another example here. Alright, so this time we're going to cross multiply. So we are doing 2 times n plus 5 is equal to 4 times 10. Now here is where you could very easily get messed up. Some of you are going to want to do 2 times n plus 5. And that doesn't work because the 2 is being multiplied by the n and the 5. That's why distribute is a step in this process. Okay, so you have to multiply the 2 by the n and the 5, not just the first term. Okay, so be very careful. This does not equal 2n plus 5. It equals, once we distribute, 2n plus 10, because the 2 has to be multiplied by the 5 as well. And then that's equal to 40, and then we can solve. We subtract the 10, 2n is equal to 30, divide by 2, and n is equal to 15. Okay? Alright, so be very careful with this. Alright, next step, same thing. We're going to cross multiply. So we're going to multiply 5 times y minus 3 and set that equal to 2 times y. And so next step is we are going to have to distribute. So it's 5y minus 15 is equal to 2y. Okay, and then I'm actually going to move the move the 5y over so that I'm not left with nothing on the other side. So I'll have negative 15 is equal to negative 3y. Then divide, and we find that y is equal to 5. Okay, and as always, you can check your answers on these. You can make sure that it works and that they are equal to one another. You just have to plug that value back in and make sure that it works. Alright, one more example here. We're going to go ahead and cross multiply. This one's going to have a little bit of extra distributing. So it's 5 times 2k minus 3 is equal to 3 times k plus 9. So we distribute the 5 and we distribute the 3. So 5 times 2k is 10k. 5 times negative 3 is negative 15. 3 times k is 3k. 3 times 9 is 27. Now we can solve this like a regular problem. We're going to have to move the variable. So I'm going to move this k over. I'm left with 7k minus 15 is equal to 27. I'm going to move the 15. 7k is equal to 42. And I'm going to divide by 7. And so k is equal to 6 in this problem. Okay, so there's a few examples. I'm going to look through and see if there's any others that we need to do, and then I will let you know which ones you need to complete for the remainder of these. So watch out for the next video.